Hello, today I'll show you how to go from this mess to this organized display. Why is this video so long? Because I'm gonna show you how to draw it. This isn't just how to put some wood pieces together. This is actually how I started designing in 2D with Inkscape, because that was the only free program I could use to draw at the time. How I retaught myself the fundamentals of 2D technical drawing to produce 3D parts in 2D and make it all come together. Sit back, relax. If you've got some spare time to learn a new skill, this is probably where you want to get started. Before we start drawing our shelf, we have to take some measurements of the thing we're designing for. In that case, that's the Nintendo 64 cartridge. So to make this shelf, I need to measure from 3 perspectives of this cart. And those 3 perspectives are needed because I'm using a 2D drawing program, so I need all 3 perspectives, which would be front, top, and side, represented and drawn to scale in my 2D CAD program. And that'll help us draw and plan around this. So you can see here I have the front, top, and side drawn to scale of the N64 cartridge. This curve on top is not necessary, but it does help with the visual. The next thing we need to decide is the overall design of how this shelf is going to be laid out. So if you have size constraints, because this is going to go on a specific shelf or table, you have to decide how wide, how tall, and how deep this shelf is going to be. And because we have our N64 cartridges drawn from 3 perspectives, we can do that here. So I've chosen to do 4 Nintendo 64 cartridges wide, which is just under 19 inches. And from the side view, this is essentially how the carts are going to be positioned in front of the other. And I chose this height because I'm trying to maximize the volume, and I only have about 8 inches to work with in height-wise. So you can see the total stack of these is about 7.5 inches, and that gives me a little room to actually pull them out from the top of the shelf. It's also mindful, if you can see the labels in front of them, that's going to actually tell you if you'd rather have this height or something else, but that's up to you. Okay, so I have all this laid out, and the next thing I want to do, since I'm ready to start drawing, but we want to turn on a grid. So a grid is a good way to be organized. So in this case, I'm going to do that by going to File, Document Properties, and Inkscape, and I go under Grids. I do Rectangular Grid. It's enabled, and it'll be visible, and it's in inches. And the key here is I want every deviation to be 1/4 inch. Darker lines are 1 inch, and lighter lines are 1/4 inches. So I'll turn that on with the Shift and number 3, and you can see I have that aligned. So I actually want to start drawing this layout from the side perspective, because the side perspective in this case will jurisdict most of the design. And I'm also going to draw from this side because this is actually where a lot of the pieces are going to mate with each other, and let this control the rest of the design from here on. So the wood I'm going to use is, and this is really important, it's 0.21 inches thick, and that's great because it'll fit between my spacing, and that means these carts will fit pretty loosely. So this is, I'm going to have some overlap here. So what I'm going to start doing is just drawing general shapes of what the shells will look like from a side view using just nice round numbers. So I have a inch wide, the thickness of that wood is 0.21, and now I have the back separator between the shelves, and that's going to be 2 inches tall, and again, the same thickness as that wood. And I want this to line up with my grid, and that's just going to help me plan accordingly. So this looks pretty good. So I'm going to copy those 2 and make this little cascade pattern go, continue on. And every time I'm going to align these up, so it should look pretty good. So we'll repeat this. And it looks like some of these are slightly off, so I'll fix that. And that's going to be the overall like side view of how our shelves are going to be stacked. So once I have that, I can essentially rough out what I want the side piece to look like that's going to contain these, and that can be just something as simple as this. And now I've essentially like roughed out the side panel of how these shelves are going to connect to each other. Before we continue, I want to exercise some discipline when it comes to drawing mechanical layouts or technical drawings and the such. And that means my perspectives need to line up with each other. So our original representation of the Nintendo 64 cart from front, top, and side, you'll notice that my layout right here was intentional. So if you look, the front left of the cartridge should line up with the top view, and that's because these are the same. This measurement is the same in both of these perspectives, therefore they're lined up like so. Same thing with the bottom, and the top. You can see it's the same height here. So this orientation, this layout, these associations need to be carried through with our drawing, just so when we start drawing pieces that are supposed to mate, like the shelves and interconnections, that happens. The reason why the side view is going to be like our master template of how we design all the pieces in this hierarchy is because everything in this part hierarchy eventually will connect to the side panel. So if you lose the side panel, essentially everything will fall apart. That's why I'm using this side perspective as the main representation of how we're going to draw everything else, and that'll become more clear as we continue. So with that out of the way, I'm going to remove our rough layout. I'm going to put these guidelines in place from the side perspective and match the front perspective with that too. And again, we're doing this to keep our head clear and make sure our layout is consistent, so every perspective of what we've drawn in 2D will match up and align with each other. And this will be more apparent as we continue with our drawing. So to do that, you're going to click and hold in the ruler bar and make sure you have your snap to midpoints or cusps in this case. And we're going to drag and hold and put all these essentially altitude lines in that represent different heights of the cartridges on the side view. So this bottom cart should match with all the front cartridges. So I'll group these together, and I'm just going to move them down until this bottom line snaps there. So I can copy and paste another row, and that row needs to line up with this bottom line. And since it's behind these, I'm going to send it back so you can see them. And I'll align them all left in a second. So I'll continue this pattern. And hopefully, if you've drawn everything correct, the top of this cartridge should match the top from the front view. And in fact, it does. Okay, so we have to continue this discipline depending on what perspective we're going to draw from and produce our parts. But from here on, the side and front perspective have enough detail to do the full layout in 2D for this game shelf. And that will then we'll be able to draw what our parts look like because there's enough detail here to essentially do the other perspective of how they are. And we'll continue that. Now we're ready to move on, and I've already done some housekeeping to this drawing because we don't need all these reference lines because I know my parts are aligned for both side and front perspective. So I've cleaned up a lot of guidelines because I don't need to reference them anymore because my two perspectives are aligned in this case. So what we're going to do now is focus on essentially the risers between each shelf. So these are the connecting pieces that will connect to the side and essentially give us the back panels for the carts to rest on and build our height for these little shelves on the bottom to connect to. So to do that, we need this front perspective to tell us how wide it is, and we're just doing something like that. So it's got to be a little bit wider than all the carts total. And that looks pretty good. And I'm just going to use a nice round number, 2 inches in height. And we're going to design from there. Now, what I want to do is I want to make some mortise and tenon joints. So this side panel can connect to the overall side panel, and that's going to look like this. And the way I want to do that is I'm going to use just 2 female square cutouts with 2 male cutouts. So this is the overall template I want to do. And if we go between the side and front perspective, they're going to mate like this, and they'll push through. So I'll show you what that looks like in 3D CAD so you can see the visual, and this is how we're going to draw it in 2D. And again, without our aligned perspectives, it's going to be really hard to do that. So I have my baseline of what that outline should look like. I'm going to turn my grid back on, and I'm just going to make sure this matches to my grid. So I can go, say, like a 1/4 inch longer and do that. So there's a couple ways to do it. You can just draw those squares where they're supposed to go. And if I want, I can do I can do path, union, and combine these. And we have something like that. Or if you want, you can just draw it freehand with the straight line segment. And again, the reason why we do this, because we're snapping to grid and we're going to snap to points, is we can essentially draw this freehand if you have a good idea of what you're trying to draw. So something like that. I forgot that part. So we can go in and add our nodes. So this is what we need. These are the risers between each shelf, and eventually you'll get this full part. So how do we determine how it mates? I'm going to turn the grid back off, and I'm going to get rid of my cartridges. I don't need them in my view right now. So I do know the top of this should align with the top of that riser. So I'm going to line these up. And now I know that these two mating parts, and I'm going to get rid of this line as well. Don't need it. So these two mating parts right here are going to intersect here. So the easiest way to do this is I'm going to just copy and paste, because I'm looking for the same width. And I'm going to mate these. I'm going to resize this so they match. Copy and paste. I'm going to align these. So that's objects, and wherever it is, align and distribute. And that opens up this menu, and I'm going to center them on their vertical axis. I'm going to color these so I can tell that they're different. And I'm going to just hold down Control and drag it sideways. And now I'm going to lock it with that. So now that gives me this part, and the little highlighted section shows me where my mating parts are. So all I have to do now is I can just continue this pattern. So if I had my side panel, I knew just what it looked like and where it's going to lay. If I position this where I want, of course I'm going to draw around it so I have material on all sides. So something like that would look good in this case. So if I copy all this and paste it and delete what I don't need, I'll have the whole locations for the mating side pieces with the risers. And I would group all this together. I can remove all the fill. And this is the part that should align. And if we cut this out, essentially all these risers should mate perfectly, and it looks like they do. So that's a process how to do all those slats. Next, we're going to take the riser and mate the runners, which is going to be this section right here. Okay, I lied. Before we do the runner, I want to add the drawing components so we can use fasteners to put this entire assembly together. So I don't want to use wood glue. I want this to, essentially, if you were to receive it, I want it to go together in a matter of minutes, and we're going to use nut and bolts to do that. So I have this mortise and tenon joint SolidWorks model that I made to illustrate the point that I'm trying to convey, because we're going to draw it in 2D, but to get a better representation, I'm going to show it to you in 3D. So we're just going to use some number 6 hardware. It's really inexpensive, probably like 4 cents for this nut and bolt together. And we're going to use it to lock these two pieces together. So we've already done the mortise and tenon on how these parts mate, but we need a way to mechanically fasten them together. So without glue, we're going to do it this way. So the best way to do that is we're just going to draw essentially the side view of this. So if I hide it and we go to a perfect side view, I'm just going to draw the outline of the nut and bolt to essentially make this cutout right here. And that's as simple as, just like we've done before, measure that with calipers or a ruler and draw it, and you should essentially have this representation that kind of looks like a little cross cutout. And we're going to put that right here on the side. So this is drawn to scale, and I want to make sure I have midpoint segments, and add a couple of these because I have to do it to the other side. So what I'll do is I'll just put that there, and you could subtract these two parts from each other, but I'll just show you how to add nodes. I'm going to use the insert key. I'll add some more nodes, and then I can just draw this part by adding more nodes together. So you want to repeat that for the other side. And I'll flip this perspective, select both, and we can do path and difference, and it'll subtract that part from the larger part. So one thing we also have to do is we also have to find the aligning mate, and that's the hole for this to go through. So we can just do an alignment, put a guideline in the origin, and this is as simple as having the right size hole for the bolt and just aligning that to the center. Align on center. And if we can translate this back to our side panel, and that lets us know where that hole is going to go. I don't need a joint on every single one. Just every other is good. So I'm going to have a mix of, for the risers, I'll have a mix of ones that have fastener hardware in them, and then I'll have a mix of ones that don't, and I can just undo what I've done, delete those nodes, and straighten that part, and that's how we're going to fasten these. So the rest will just be more mortise and tenons between these two parts. We're ready to design the last critical component that completes this assembly, and that's the runner, or the actual shelf part of this shelf where the cartridge sits on. So in between our drawing, I've changed the design a little bit. So this is the overall depth of the runner. It's going to be about 1.21 inches, and you'll notice that it overlaps both risers in front and back of it. And all that means is I'm going to have a joint or mortise and tenon joint between the two. So there's overlap here and overlap here, and that means at some point they intersect each other, and I'll show you what that looks like in the CAD right now. So we have the overall width of it, so 1.21. So if I just copy that, and I'll give you a hint of, this is essentially the template that we're trying to produce. So if I translate that design from that same perspective, you'll see that these are close about the same width. There's some deviation sometimes when I draw. But now we have to switch to the top perspective. So you can see this is the Nintendo 64 cartridge, and this should fit with space in between it, between the front and back of the interior width of this new part. So these are the actual tenons that are going to mate with the front and back risers. So again, this design just stems from, it's got to be as wide as all the carts end to end, maybe a little bit more, so there's room. I'm going to align our drawings here. And you can simply just pick where you want these tenons to be. So again, if you were starting from scratch, you'd have this, whatever this width you want to be, match this. So this is 18.5. So we'll do 18.5, and the overall width. So we'll actually I'll just show you how to add the tenons by hand. The overall width is this measurement right here, which is 0.79 inches, and that should match the width of our cart. And I'm just going to pick a uniform width for each tenon, and that's It's going to be an inch wide, and we'll just do 0.19, so it's a little bit, the tenon is thinner than the actual overall thickness of the wood. And you can pick these wherever you want arbitrarily, but if I want to do like exactly in the middle, I'll make sure my midpoint is on. And you can see as I drag, this will snap to that midpoint. I can copy, paste the one below, and we'll just do a measurement. So if I want, I'll just do this offset right here, and that could be, in this case it's 5 3/4. So I'll just put that there as an alignment, copy and paste and put that there, and I'll repeat this process for the one below. And again, these squares are just helpers. They don't do anything but help me get my measurements, because we're drawing in Inkscape and not SolidWorks. So again, Inkscape is free. It's a great program to get started with. So there's my part, and I'm going to add these together. So that's path and that's union, and note that the Control plus is the shortcut. So we'll do that. Okay, so I've drawn my mating piece, and we need to figure out how it's going to mate into the riser. So I'll just pick one of these as a template, doesn't matter. And this is where it's going to get tricky. So I'm going to move my front out of the way, and I'm going to align this piece right here. Goes there. I don't really need this reference line right now. And I'm going to pull up the mating front piece, and now we're going between a couple different perspectives. So this is where you have to kind of wrap your head around what's happening. So this is a front piece, this is a top piece, and we have the side piece. And our mating lines are going to tell us essentially where this hole has to go. So I'm going to draw in those guidelines. So that's that tenon, and I want its hole to be right here, because that's where this piece goes. So I'll mark this and this, and this is showing me my mate on this piece. So this piece looks like it's a little bit longer, so I'm gonna, because I want that tenon right there, I don't have enough material left, so I'm gonna make this piece a little longer. And now I'm going to draw those lines. So this essentially tells me that this is that mating piece, and that's where that tenon goes. So we're going to repeat that process everywhere. So I've added a little bit of length to these. So if we do these guidelines, we get the same one. And if we do these guidelines, we'll get the other. So now if I take this whole part, copy it, and I paste it, and I'll make sure the colors are all the same. So we now have that front bottom part. But remember, so this part, so we have the essentially front mate, but we have to make another set of tenons right here so the piece behind it can mate as well. And we simply repeat that same process again. So I need these guidelines to match on this one. And so now we'll have that set too. So I'll just copy and paste those in, put them where they go. And if I remove this from my guides, you can see I have the two mating lines. So now we have the holes to mate the front piece and the holes to mate the piece behind it, which goes a little bit higher, and that pattern repeats. So this little guy, this riser now will mate with this runner. We have one last unique piece to create, and that's the front of all this. So if we look at our overall assembly, just for visual aid, this piece is unique to all the risers. We couldn't use another riser on the front, so we have to draw that, and we'll do that now. Just as a reminder, we have the two different risers, one with hardware cutouts, one without. You could make them all with hardware cutouts. It really doesn't matter. You're not going to see them. We have the side panel, and we have the runner. So I'm going to remove the reference lines that make the alignments for the riser. Delete those cutouts. We still need the runner to do our mortises, and this is the part we're going to make. So I'm going to decolorize things that we're not focused on. This is what we're trying to produce. This guy right here. One thing we do want to fix right now, since it's in view, is we need the reference line for the bottom of this part. And the thing that I've drawn, there's another tenon here, so I want some material left over. So looking at this right now, the bottom of the side panel doesn't go down enough. So we'll just fix that with another reference line, and we can elongate that at this point. So that's fixed. So now I need the reference lines for the overall size of the piece. I'll get rid of that one, doesn't matter. And I'll put the side tenons in. We'll draw that first, and then we'll do the front and back tenons. So I'm going to draw this overall piece. So I want the tenons for the left and right sides, and one is going to go out at this point right there. We have our outer references for how big this thing is, so I'll draw that. Sorry about the colors. I'll combine these shapes. So we have those drawn in, and I'm going to do the other reference line that's for the tenon in the back, or front in this case, and those will line up right here. And if I want, I'll just color those so they're clear. All right, so that's that front piece, and that's going to be this guy right here. And those are all our unique parts. So one thing I want to do is I want to do some cleanup, because I'm planning to laser cut this. So if we look right here, this is the full layout. This is the full layout for all the laser cut parts. And if you notice that to condense things to one sheet, I've actually taken the runner and I split it in half. So it's actually, so it looks like this, that's the full size, but I can split it down the middle just to condense some area and use up some material that I have already cut to size that fits on a standard size laser cutter. But cutting these at full 18.5 inches just isn't really efficient. So I'll show you real quick how to cut this. It's pretty easy just to put a reference line that goes to the midpoint. And if we convert to nodes, we can just delete all these nodes. And if we want, we'll straighten that, and we don't need two sets of nodes there. And I'll straighten that. And then this can move. Hold down Control, and that will move there. So we have two of them. I'll paste another one, flip it. And now this entire part can be condensed and nested to that size. So yeah, that's the layout. The next step at this point, I would essentially check yourself. So before you commit to cutting this and using material, I would import, if you can, take your 2D drawings, import them to your 3D CAD of choice. So I'm going to use SolidWorks. But you can use 123D, which is free. You can use Fusion 360, which is free, and essentially convert these files to DXF, and then import them one at a time. So we'll do that together. and assemble this model. I'm going to skip all those 3D stuff because I want to essentially keep this to 2D. But this is a great way to check your drawings and to reinforce the best practices and disciplines of 2D perspective drawing to make sure what you're doing makes sense and it actually works in the real world. I'm going to briefly go over how to convert our 2D drawings into 3D. This step is totally optional, but it's a good way to segue into 3D if that's something you want to do, and this is also a great way to check our drawings. So I have all the unique parts laid out, and they're just saved in a new file, and these have to be saved as a DXF. So this is the most compatible file between 2D and 3D drawing programs. That's why I'm doing it. One thing I want to note is the units for this DXF conversion are in millimeters, so that's something we have to pay attention to. So in SolidWorks, in the new part area, I'm going to open that DXF, and the wizard is going to pop up. I want to tell it that this is going to be a 2D sketch that I want to use as a part. I'm going to make sure the imported units are millimeters, and again, you can see that's what the default was when I imported it. It doesn't matter, just make sure they match. You have the option of to pick what layers the drawing's on. And in the next step, this is just kind of a catch-all that I like to do. If any nodes aren't close enough to form a fused part, I'm going to tell SolidWorks to automatically fix that, because if you have an open vector, it won't come into a part. So the process is I'm just going to use this file to extract all the parts, delete everything but one, and then extrude that to a 3D part, and that's the process that I have to essentially take all these parts laid out in one file and make them into a 3D part. And this is, again, if you have it natively drawn your 2D stuff in a 3D program. Inkscape is free. Not everybody's going to have a SolidWorks license. So again, I'm teaching you these 2D fundamentals to do this. So I have that part. I'll just save it to 2D. And I'll just show you again, we'll repeat the process really quick. And you just do this for as many parts as there are until you have all your unique parts in 3D, and then we can assemble them. Here's what the 3D assembly looks like if you just blast through it. So this is like a 32x time lapse of me fumbling through 3D assembly with all the parts. And so just as an aside, I didn't draw or model the nut and bolt. You can actually grab that from McMaster Car, but that's another video. So again, the whole purpose of this is just to make sure our mortise and tenons, because we have parts that rely on references of other parts, hopefully we drew them correctly in perspective so that all those parts do align. And in fact, if we look at like the final assembly, I'll just colorize it just to have that feel. Everything looks pretty good. Okay, so now I guess we put it together. Well, if you made it this far, thank you. I'm going to throw up some extra footage over here, and that's where to download 3D files for some basic hardware parts like nuts, bolts, screws, and that's from McMaster. So I took this footage, but I didn't really know where to put it in this video. But the whole point of this video is to get you started with drawing. So the way I started, the first program that became immediately available to me to start doing 2.5D like production on laser cutters and CNC machines was Inkscape. So Inkscape is like free, there's no strings attached, but if you're going to start 3D modeling, just start in 3D CAD. The point of this video is to reaffirm some technical skills that will help you with your development in 3D modeling, 2D modeling, anything essentially CAD related drawing. And that's the technical drawing, mechanical drawing disciplines of looking at something in 2D but making its 3 perspectives to essentially build and understand how that part is laid out and viewed from those different angles. This was how I started drawing my arcade cabinets, and it's still a useful skill because it rewires the way your brain thinks and how you can visualize parts in 3-dimensional space when you're planning and drawing. I hope you enjoy this video. If it does get enough traction, I'll continue to make these like tutorials on how I do CAD. Of course, they'll be like video game related, but the whole point is, if this is something you're interested in, pick a project that you're passionate about. The investment in that will see you through to completion, and that's going to help polish and develop those skills. Thank you for watching.